A couple of weeks ago, I uploaded a video about the double-slit experiment. The purpose of this video was to capture some of the excitement that comes with learning about a new physics idea for the first time. For this reason, I chose to use the Dr. Quantum double-slit explainer video and got some of my friends to react to it. I chose this video because it was reasonably short and explained some of the aspects of the double-slit experiment in a reasonably engaging and fun way. But that video isn't perfect, and especially since the video of mine got more views than I really anticipated it to, I feel like I want to clarify a few things. The main problem with the Dr. Quantum video, as pointed out by many of you in the comments, comes when it starts to discuss using a detector to determine which of two slits a particle goes through, as it appeared to be going through both slits and interacting with itself to create an interference pattern. When the detector is used, the particle goes back to behaving classically. It only goes through one slit and the interference pattern on the wall is lost. This is called a which-way experiment. In the Dr. Quantum video, they use an eye to represent the detector, and they say it is as if the particle knows it is being watched. But this is a bit misleading because in reality the detector is measuring the particle, and this measurement is interacting with the particle. It is this interaction that causes the interference pattern to be lost. A quantum particle moves as a wave of probabilities of being in any location. Its exact location is unknown, and if you were to measure its exact location, you would collapse the wave function. This would also cause you to lose the interference pattern, which is caused by the wave-like nature of the quantum particle.
After years of discussion about whether matter was indeed a particle or a wave, one of the biggest questions in quantum mechanics is about the role of the human observer in an experiment. That is, whether the presence of a human or a conscious observer can affect the results of a quantum experiment. There are differing views on this, however, which conclusion is the most reasonable in light of experimental evidence, and reasoning requires one to go to very basics of quantum mechanics. And with the help of two of the most important figureheads of the quantum revolution, so as to speak, Werner Heisenberg and Erwin Schrödinger, we will see whether we can shed light on this. Schrödinger gave Schrödinger wave equation, which is an equation which can be used to find the likelihood distribution of a quantum particle with respect to three coordinate axes and time. The probability density function defined by phi when squared and solved gave us the probability of finding a quantum particle at a specific point in space. The visual representation of the area where the quantum particle can be found can be called the particle cloud, or in case of electrons, an electron cloud. One of the interesting things to note is that the extent of this cloud is infinite because there are no theoretical constraints or boundary conditions on Schrödinger's equation generally, which means at any given point in time, the particle cloud of any particle is interacting with particle clouds of essentially all particles in the universe. If such is really the case, and interaction is occurring at all times, the particle in question must always be collapsed and will never be in a wave form. Unless, of course, one says that the particle cloud has no more meaning in real world than a sample space of all outcomes of throwing a six-sided dice. That itself poses a serious problem that can be discussed later. Let's assume for time that the two particles are in interaction if the extent of the wave cloud around them is in interaction. Yet such an interaction is without collapse. So what makes this interaction different than any interaction used to measure the position of the particle, which the video we saw described as being behind collapse of the particle? To understand the difference between interaction and measurement, let us think of a simple experiment. After each setup, one may think when, according to them, an interaction becomes a measurement or a measuring interaction. Let's assume for the experiment that a bulb is connected via two thin strips of copper to a battery, forming a complete circuit. This is the first setup. In the second setup, we place a coil mounted on an iron core in between one of the copper strips, in such a way that the circuit is still complete. In the third setup, we place a permanent magnet alongside the coil, in such a way that the field of the coil is repulsed by the field of the permanent magnet. Now, in the fourth setup, we attach a needle to the coil, which moves as the coil moves, when it experiences a repulsive force by permanent magnet. Can, at any point in time, one say that we are measuring anything if we are not measuring anything? Is the force setup a measurement device? If yes, what makes it so? The needle, the permanent magnet, the coil, the iron core, the battery, the copper strips, the bulb, or it will only be a measuring device, a crude moving coil emitter of sorts, when it is being used as a measurement device. If that needle movement is, let's say, being used in RUBE Goldberg machine to do a function, let's say hitting a styrofoam ball to activate some contraption, is that still a measuring device? Let us look at another experiment to get more understanding of the phenomena. In order to find depth of water in a well, a certain technique can be adopted which gives a rough but usable measurement. A person can drop a pebble in the well and at the very same instant start calculating the passage of each second roughly in his head. And when he hears the splash of the pebble in the well, he stops and then puts the time he gets in some equations to get the depth of the well. Is that a measurement? Seems so. But what if a kid just drops a pebble in the well, hears the sound of the splash, chuckles, but calculates nothing? Is it still measurement? Remember, in both cases, the pebble distorts the position of the water in the well, as Heisenberg's uncertainty principle says. But that is not the question that is being discussed here. What makes one setup a measurement and the other not a measurement is merely the presence of mental factors, which of course are associated with humans and not with measuring devices. The role of human observers is indeed thus significant in the experiment unless one accepts one of these three premises. The interactions of quantum particle, firstly, and the interactions of probabilistic field of the particle are different events, and only the former leads to a collapse. As asserted earlier, this is problematic because this means that the particle, even when not collapsed, is still in particle form and thus cannot go through two slits at the same time and must go through either one of them or none. Secondly, one may believe that the Schrödinger equation does not allow quantum particle to be present at relatively large distances with any degree of probability, and the boundary conditions for the equation exist. And that allows a particle to only collapse if there is another particle very close to the first particle. This, however, means that proximity causes collapse, which is questionable, as there may be many particles which are as close to the particle in question as the particles of the measuring device, and in that situation, it must be asked whether those particles will perform the same role as the measuring device. The third premise, which may be used to justify the limited or no role of the human observer, may be by objecting the role of human observer on the grounds that the interaction of a particle with a measuring device is indifferent than an interaction with a non-measuring device, even though every component except human cognition or consciousness is same in both setups, which means that any other property which we have no account for that differentiates the two must be constructed, which seems more non-parsimonious. None of this proves, however, that a conscious observer plays a role in the results acquired of an experiment, but it shows that such a belief is philosophically warranted and will go on to persist even though flouting the materialist presuppositions. Mind indeed may have a huge role to play that the matter simply cannot, and in that matter, the matter is handicapped.